Okay, in this video, we're going to be talking about three variable systems of equations. So you have three variables, you have three equations, and we're going to now look for, instead of an ordered pair, an XY answer, we're going to look for an XYZ answer. The solution to a system of equations with three variable is an ordered triple, an XYZ, that satisfies all equations. You should be able to plug all three of those back in, and it should make all three equations a true statement. Three variable systems can have one solution, no solutions, or infinitely many solutions just like before. Here's how we solve it. We're going to eliminate a variable from a pair of equations. Then we're going to eliminate the same variable from another pair of equations. And we can do so using substitution or elimination. Then we're going to solve the resulting system of equations from step one, and we're going to substitute to find the third variable. So let's show you how we do that. So solving each system. So we can again use either substitution or elimination. I'm going to start out with using substitution here. I notice in my first set of equations, or my first equation here, that I can very easily get x by itself by simply moving the other two variables over. So that's going to be x is equal to negative 3y minus 2z minus 13. Now what I'll do with that, I'm going to take my other two equations, and in the place of x, I'm going to substitute in what I just found. So here's what my second equation turns into, and here is what my third equation turns into. And again, all I did there was I pulled out the x, and I substitute in what it was equal to into the other two equations. Now, it's very important that you make sure you plug that into the other two equations, one at a time. Now, I'm going to take each of these, I'm going to clean them up, and simply combine my like terms. My first equation looks like this, and my second equation will look like this. And notice what we now have. We now have two equations with two variables. So what we do here is simply solve this like we did before, and then we're pretty much finished. So let's group these together. Now, if it does reduce, like this second equation will reduce, I like to reduce that down as I write it. So I have negative 13y minus 12z equals 54. Not much you can do with that. But my second equation, I'm going to go through and divide everything by negative 5. So that's going to give me a positive 5y, a positive 3z, if you divide by negative 5, and a negative 24. So there's my new system that has only y's and z's. Now let's solve it like we did the previous ones. So you can use either substitution or elimination now. Even if you start with substitution, now you can use elimination if you want to, which is what I'm going to do. I notice my z's can be very easily eliminated. The first equation will stay the same. The second equation, I'm going to multiply everything by 4. Gives me 20y plus 12z equals negative 96. My z's now cancel and leaves you with 7y is equal to negative 42. So therefore y is negative 6. Now that's one of your three answers. Now to get your other answers, you can go back to either here or here. Notice these two equations have only y's and z's. I'm going to plug this y back in, and I'll just use this one. Plug those y's back in, and here's what you get. And when you move the 150 over and divide by negative 15, that tells you that z is 2. So now you have your y's and you have your z's. So how do you find your x's? Now go back to the original. And you can use any of these, or this is going to be our easiest spot. Since we know y is negative 6 and z is 2, let's plug that in. We now have x equals negative 3 times negative 6, which is 18. Negative 2 times 2, which is a negative 4, minus 13. So therefore, x has to equal 1. So therefore, my solution, my ordered triple, we write it as an x, a y, and a z. So therefore, 1, negative 6, 2 is our answer. Okay, number 2. Now this one's not going to be, well, maybe it is. It will be fairly easy to solve by substitution. So what I'm going to do, take your third equation, and let's solve this for x. And we now take that and plug it into our other two equations. 4x minus y plus 9z equals negative 3, and 3x minus 4y minus 5z equals negative 31. Plug this x equals in each equation, and here's what you'll get. Then you simply take the two equations and you simplify them. Combine your like terms. I like to put them in standard form to where my y's and z's or my other variables are on one side and my constants on the other. And here's my two new equations. What you now have is two new equations that contains only y's and z's. So again, from here on down, it's just like our old material. Solve these by using either substitution or elimination. It does not matter which one, but you can think of it from here on down as a new problem. Now this is a tricky problem because substitution is going to be horrible because you're going to have ugly fractions. So we're going to try elimination, and the way that I'm going to do that is I'm going to take my first equation. We'll try to get y's to eliminate. I'm going to multiply my first equation by 17, and 17 times 27 gives you a number, and I'm going to take my second equation and multiply it by negative 27. So obviously these will be the exact same numbers when I do that. Here's your two new equations. Now notice your y values do cancel here. So my two new equations, y values are gone. Combine our z's, and here's what you're left with. When you divide by 145, you will then find out that z is equal to 3. And most of these, they create where they come out to be nice, neat whole numbers like that. So if you get a nice, neat whole number like 3, you're pretty confident that you're right. Now, to find the other ones, take that z value, and you can now plug it into either one of these or either one of these, and that's going to tell you what your y value is. So I'm going to plug it in here, and here's what I get. And when you subtract 84 and divide by 17, that'll give you a y has a value of negative 2. So there's your y and your z now. And to find x, you can then go back and plug it into any of these up here. I'm going to plug it in here. So I have x equals 7 times y, that's negative 14. 11 times z, so that'll be a positive 33 minus 27. So therefore, that tells me that x has to be negative 8. So therefore, my order triple would be negative 8, comma, y, which is negative 2, comma, z, which is 3. There's my solution. Number 3. Now we've used substitution, so now let me show you how to start out with elimination. So pick one of the three equations. It's very nice to pick one to where it has a variable by itself. It's just a little bit easier to work with. And what you're going to do, you're going to pair that equation with each of the other two, as I have done here. So notice, again, this third equation, I've paired with the first equation here, and I've paired with the second equation here. And again, it doesn't matter which one you pick, it'll work just fine either way. Now, the next step is very important. We're going to eliminate the same variable in each group. So since y was by itself, it's going to be very easy to eliminate y here. And I'm also going to try to eliminate my y's here. So in my first group, to get my y's to leave, I need a positive 5 here. So I'm going to take my second equation, and I'm going to multiply everything by negative 5. And that's going to give me that positive 5. So the first equation stays the same. But my second equation, I multiply by negative 5, and I get this. So now when I add these two equations together, again, you can see my y's cancel, and here's what I'm left with. Now let's do the same thing for my second set of equations. Again, eliminate the same variable, so I'm going to eliminate my y's. So my first equation is going to stay the same. However, to get my y's to cancel, since I have a positive 7 here, then I need a negative 7 here, so I'm going to multiply everything in my second equation by 7. And now when I add these two together, my y's do cancel, and here's what you're left with. So again, now look at the scenario you have. You have two equations here and here that have two unknowns. So we now set those equal to each other, or not equal to each other, but we pair them together. And you now either use substitution or elimination to solve these. And again, that's going to be the exact same as we did before. What I'd probably do here is multiply your first equation by 59, multiply the second equation by 43, and your x's would cancel. Regardless of how you do it, here's going to be the x and z that you get. And now that you have that x and z, you can go back to your original problem, and you can plug it into any of these three. Just pick one. I'll just pick the first one. It doesn't matter. So you have 2 times x, that's going to be negative 8, minus 5y. Negative 6 times z would be a positive 60 is equal to 57. Combine these, that's going to be 52. Move it over, it gives you negative 5y equals 5. So therefore, y would be negative 1. So therefore, your answer is going to be x was negative 4, y was negative 1, and z was negative 10. There's your ordered triple. Number 4. I'm going to try again to solve this with elimination. The method is pick any equation. It's best to work with one that has a x, y, or z that can very easily cancel out something in the other equations. And I'm going to pair this with one at a time. I'm going to pair it with the other two equations. And now you're going to choose which variable do you want to eliminate. Now, since my z was by itself here, I'm actually going to pick z, and it has to be the same one in both sets of equations. So I'm going to eliminate z in both sets. So to get rid of z, since I have a negative 2z here, I'm going to take everything in my first equation, multiply by 2, and I'm going to leave my second equation the same. Now, when I combine the two equations, my z's will cancel, and here's what I'm left with. Now on to my second equation, or set of equations. Let's again eliminate the z's. I'm going to do that since I have negative 3z here. I'm going to multiply everything in the first set of in the first equation by 3. And I'm going to leave the second equation the same. And when I combine it, here's what I get. My z's will cancel, and here's what I get. So now I have two new equations with now only two variables. Let's pair them together and let's solve that system. In order to do that, you could turn both of these into maybe 70s by multiplying by 5 and negative 7. You could turn them into 140s. You could multiply to form these, or to turn these into 77s, to where multiply this by 7, multiply this by maybe negative 11. But any of those methods will work. But here's what you're going to get for x and y. And now that you have your x and y, we go back to the original. We plug it in to any of these, and you'll find out that z is equal to negative 7. So therefore, your order triple here would be 3, negative 3, negative 7. Number 5. There's a few different ways to work this, but the thing I notice is this is missing a y. So if you want to take these two and somehow eliminate the y, then pair it up with the other one, that would be fine. I'm going to solve it with substitution. I'm going to take my first equation. I'm going to solve it for z, and that's going to be z is equal to 8x minus 7. And then in my other equations, this one I don't have to do anything, but right here I'm going to solve or plug that in for my z value. And then once I take and I solve that down, I should only have x's and y's left. Clean it up, and here's what you get. Okay, now that I've done that, I've used these two equations to form this new one. Now I'm going to take my original, my first equation up there as well, and I'm going to pair it with it. 8x, well, actually, no, I'm not. I'm going to take my second equation because I used this one and this one to form this new equation. So now I'm going to pair it with this middle one. 4x plus 3y equals negative 31. So now I have two equations that have only x's and y's. I would probably use elimination, multiply the second one by 4, and the x's will cancel. But regardless of how you do it, here's what you get for x and y. You can now take those x's and y's, and you just need one of the equations that has a z in it. This is going to be your best place. Since x is 2, that's going to be 16 minus 7, so our z value will be 9. So our order triple is going to be 2, negative 13, 9. Okay, starting with number 6, we're now going to be working some application problems. Now what I'm going to do, I'm just going to show you how to set these up. I'm not going to go through the actual process of solving them all because they take so much time. So we're going to set them up, and then I will solve them and show you what those answers would be. Mischa, I guess is how you pronounce that. Mischa and Ben's combined SAT scores was 2290. Ben and Ashley's was 2530. Mischa and Ashley's was a combined 2660. Find each student's individual score. So obviously we know what our X, Y, and Z are. So now let's take that let's say Mischa and Ben, which is X and Y. X plus Y has a combined score of 2290. Ben and Ashley, which is Y plus Z, has a combined score of 2530. And then Mischa, which is X, and Ashley, X plus Z, is going to have a combined score of 2660. So there's our system. And again, you can use substitution or elimination. What I probably would do was take maybe your first equation, solve it for x by moving this over, plug it in for an x down here, and then you will have all y's and z's here. You'll have all y's and z's here. And once you combine those two or put those two together and solve them, here's going to be your x, y's, and z's. Mischief's score would be 1210, Ben's score 1080, and Ashley's score would be at 1450. Number 7. Jada has 33 coins in her wallet. They're all pennies, nickels, and quarters, which already shows you what your X, Y's, and Z's are going to be. Total value is 341. The number of quarters is 4 less than the number of pennies. How many of each coin does she have? So your X, Y's, and Z's will be the numbers of pennies, nickels, and quarters. And we know the total value is 341. Now let's do this instead of $3.41. Let's write it as cents. So each penny is worth 1 cent. So 1 times X tells you how much it's worth. Each nickel is worth 5 cents, so 5 times Y tells you how much they're worth. And each quarter is worth 25, so 25 times Z, that tells you the worth. But again, I did it in cents, 1, 5, and 27. So when you add it together, that would be a total of 341 cents. So there's my first equation. Second equation says the number of quarters, which is going to be Z, is equal to, is 4 less than the number of pennies. So the number of pennies minus 4 less than. Is that all that they give us? Oh, there's 33 total coins. So we know that X plus Y plus Z is also equal to 33. I knew I needed 3 equations there. To solve this, probably the best way, since you have Z is equal to X minus 4, why not go ahead and plug that in to our other equations for that Z? So then you have these 2 equations, which will now only have X and Y values. Whenever you solve that, here's what you're going to get. There are 16 pennies, 5 nickels, and 12 quarters. Number 8, 3 solutions contain a certain acid. Solution A contains 15% acid, solution B is 5% acid, C is 40% acid. A chemist combines all 3 solutions to create a 60-liter mixture containing 29% acid. Twice as much of solution C as solution A was used. How many liters of each solution was used for the mixture? So that last sentence usually tells us what our X, Y's, and Z's are. So that's going to be our 3 solutions. So now let's try to figure out 3 equations here. So we know that there's a 60-liter mixture, so that's therefore the amount of X plus the amount of Y plus the amount of Z has to add up to 60. Solution A contains 15% acid, B 5, and C 40, and we want to combine it to make a 29% solution. So we've got to be a little bit careful with this. So solution A is 15% acid, so that means 15% of solution A is acid. Solution B is 5% acid, so that means 5% of solution B is acid. And 40% of solution C is acid, so 0.40 times Z, that tells you how much acid. Now, we create a solution that is 29% acid. So our entire solution is 60 liters. 29% of that will be acid. So we're going to do 29% of the 60, and that tells you how much acid. So this acid plus this acid plus this acid is going to create a new solution that is 29% acid. So we're going to do 0.29 times 60, and that's going to give us 17.4. So there's going to be our second equation. And again, we could go through that and we can multiply everything by 100, and that would actually do this. It's going to get rid of this decimal. It's going to turn this into 5y. It'll turn this into 40z. It'll turn this into 1740. So that's, if you want to clean up those decimals, that would help. And the last thing we know is there's twice as much solution C as solution A. So therefore, the amount of solution C that we use is double the amount of solution A. So we like this equation because now what we can do is take that, and everywhere we have a Z, we could replace it with 2x. Then you have 2 equations that have only x's and y's, clean it up, and then you're going to solve from there. And you're going to find out that the amount of each solution that you use is equal to 18, 6, and 36 liters. Okay, number 9. Again, we're just setting this up. In last weekend's track meet, Lakeland High School had 30 individual event placers score a total of 111 points. First place finisher scored 7. Second place scored 4. Third place scored 1. The number of first, second, and third place finishers was twice the number of first and second was twice the number of third. Find the numbers of runners that finished in each place. So there's how we're going to set up our variables. We have, let's see, 30 individual event placers. So therefore, there was 30 different events. So therefore, the number of X's plus Y's plus Z's would have to equal 30. There's your first equation. You got 7 points for each first place. You got 4 points for each second place and 1 point for each third place. So that'd be 1 times Z. When you add those together, they got a total of 111 points. And then finally, it says the number of first and second place finishers, which would be X plus Y, was or is equal to twice the number of third place. So is equal to 2Z. Take this system, solve it, and here's what you're going to get. There were 7 first place, 13 second place, and 10 third place finishers. Number 10. Marvin inherited $25,000 from his grandparents. He placed the money in 3 different accounts, earning 2, 6.25, and 8.5 simple interest. Again, interest is principal times rate times time. The amount of money placed in the account earns 2%. That earns 2% was half the amount placed in the 6.25. He earned $7.29 in interest combined after 1 year. How much money did he place in each account? So there's how we're going to split up our variables. He inherited, it was a total of $25,000. So the amount that he placed in the 3 accounts will be $25,000. Let's go ahead and use the 1729. That's how much interest he earns. So the 2% account, he's going to earn 0.02 times X in interest. The 6.25, he's going to earn 0.0625 Y. And the 8.5, he's going to earn 0.085. And those 3 amounts of interest combined is going to be a total of 1729. And the last thing that we need, it says the amount of money that he places in the 2% account is half the amount he placed in 6.25. So the amount that he placed in the 2% is equal to half of the amount that he placed in the 6.25. Now, what I would do there automatically is that 1/2, I would move it over. So therefore, multiply by the other side by 2. So X, double X is equal to Y. And that does make sense because the amount he placed in Y is going to be double, or the amount he placed in X is going to be half. So since I've got this equation, again, definitely substitution. Everywhere you have a Y, I would place 2X. That's going to give you two equations that have now only X's and Z's. And when you solve it, you're going to find out that X, Y, and Z are equal to 3,600, 7,200, and 14,200. Number 11. Beth bought 1.5 pounds of cashews, 2 3/4 pounds of almonds, and 2/3 pounds of raisins, paid $23.75. Clara bought 3/5, 1 5/16, and 2 pounds for $14.25. The cost per pound of cashews is 50 cents less than twice the cost of almonds. Find the cost of each pound that she bought. So there is where we define our X, Y, and Z, the price of the almonds, or cashews, almonds, and raisins. It says she bought 1.5 pounds of cashews, so 1.5 times X. She bought 2 3/4 pounds of almonds, so that'd be plus 2 3/4 Y, plus 2/3 of a pound of raisins, so 2/3 Z, and that price was $23.75. Next up, Claire bought 3/5 pounds of cashews, so 3/5 times X. 1 5/16 of almonds, so 1 5/16 Y, and then 2 pounds of raisins, so plus 2Z, and she paid $14.25. And finally, the cost, if the cost per pound of cashews is 50 cents less than twice the cost of almonds. So the cost of cashews, which is X, is 50 cents less than twice almonds. So here's twice almonds, and then 50 cents less of that would be minus 0.50. And I would definitely start here. X is equal to this. So everywhere we have an X, which is here and here, you can turn these into decimals. You're going to plug that in. You now have two equations that have only Y's and Z's. Solve that, and you're going to find out that X, Y, and Z are equal to $7.50, $4, and 2 1/4 per pound. There is your answers.